And let's start off with a great, absolutely great rockin' math problem of the day. Let's see what we got. In a right triangle, the hypotenuse, that's the longest side, that's the opposite of the right angle, measures 15 inches. If one acute angle measures 35, find the length of both legs. All right, so we've got a right triangle, a hypotenuse given to us, 15 inches. If one acute angle measures 35 degrees, find the length of both legs. All right, that just doesn't sound like a lot of information, does it? So many times when we look at right triangles, we're talking about a squared, b squared, and c squared. So today, let's take a look at this guy, and I'm going to go ahead and choose where we're going to put the 35 degrees. All right, it's really immaterial. It's got to be one of the acute angles, because over here, my friends, there's your big old right angle. That is your 90-degree moment. All right, now, what else do we know? We know the hypotenuse. And the hypotenuse, as I said, it was this side that is opposite. It's opposite. It's all the way across from the right angle. These two guys are called legs. Now, some of you say, well, Ernie, how did you know to put 35 down there? I just put it there, okay? If we had a problem where we were using a word problem type setting more so than what this is, we'd probably be talking about like an angle of elevation. That would place it where it is. Or the angle maybe a ladder makes with the wall here, that kind of thing. Those are the practical applications of this stuff. But what we're going to do, we're going to just say it's right down here, because we're going to find out both of these. We're going to have both of these. So I'm going to call this little guy over here, call it X. And this little guy down here, call it Y. I do know one thing. Answers are going to be smaller than 15, because the hypotenuse has to be the longest side of this triangle. So let's take a look at it. Let's see where it's going here, all right? Let's test it out. I am going to look at X and 15, and the story here is, in terms of my 35-degree angle right here, that is opposite over hypotenuse. So you say, well, what does that have to do with anything? We're going to do some trig. We're going to do some trig functions here. That's how we get through a problem like this, when we only know one angle and one side, and we know it's a right triangle. So actually, you know, two angles, three angles, because right, 180 degrees in that triangle. So we could go up to the top and work there also, but let's just go ahead and play this one out. And those of you who've had trig in high school math, your geometry, your algebra 2, goodness, your pre-calculus, your calculus, notice all those courses, it keeps coming. So you're going to be using this stuff quite a bit on down the road. So it is practical, very much so. And going back to it here, let's see. I have the sine of, looks like 35 degrees. You say, Ernie, why are you doing that? Why don't you do that? Because I am talking about the opposite over hypotenuse, and that is the ratio. Opposite leg over hypotenuse is the ratio that is called the sine of 35 degrees. So you say, well, what does that mean? That means it's X over 15. Now, yesterday we had that tree problem. We were using some of this trig stuff then. I'm just going to go back and use this. It was just timely that we had this chosen as a problem of the day today. But what's going to happen here, it's a simple proportion. It's a simple proportion. We're going to cross multiply, and we're going to let the calculator do some of this work for us. Because I'll be honest with you, I don't know what the sine of 35 degrees is, and I don't know many people who do. They'll rely on technology to take care of that for them. But what happens when we cross multiply? Well, we get X equals 15 times, I'm going to put let parenthesis there, make multiplication out of it, 35 degrees. All right, so 15 times that. Now, whatever I get, that's going to be my value for X. And we'll round it off a little bit just to make sure we're happy, all right? So let's test it out. Let's see what happens. Go to the calculator with me, guys. Let's see what we got here. Got 15. We are going to multiply that times the sine of 35. And let's see where it goes. I'm getting about 8 point, well, you got a lot of rambling there, because he's trig, but basically it's approximation. We're going to take it to the nearest tenth, all right? I'm going to say approximately it's going to be 8.6, and these are inches we're talking about, so there you go. So there's our first guy right there. Now, you can go a squared, b squared, and c squared. However, I'll say this. Remember, that's rounded off. So that means this is going to have some round-off error also. In fact, we'll probably have some round-off error when we go with the trig. But let's go with the trig function. Now you say, Ernie, you used sine for this one. I sure did, and I just worked right through it. Bad boy. All right, that's 8, by the way. That's 8.6. Let me put it right over here so we know what we're going to call it. All right, let's go for y. The y is a different relationship to 35. It's not opposite. The y is next to it. We call it adjacent. and that's adjacent over hypotenuse. That is called cosine. And on your calculator, some of you are going like, oh, that's what that COS is about. That's exactly what it's about. It's the cosine of 35 degrees, and that will equal the adjacent over the hypotenuse, all right? And that's going to be y over 15. Now, in taking a look at that, guess what? We're going to cross multiply. Put the 1 under there. Let's cross multiply. I'm going to back it up to the left. I'm running out of space here. So when I cross multiply this way, I get a y. When I cross multiply going this way, I get 15 times whatever the cosine of 35 is going to give us. Now, let's use the calculator. That's the best way to know on this one. Let's see, we got 15 times cosine 35. And I'm getting about 12. We'll round it off again to the nearest tenth. How about we'll take that one approximately to 12 and 3/10, and that is also inches. So there we have our calculations going there. So the values here, we've got 8.6 on this one. We've got about 12.3. They're all inches, by the way, all right, because we started out with 15 inches up there. Now, some of you may say, all right, is there any way we can check this? Let's do it. Let's take a look, and there's a way we do it on the calculator. Let me kind of point it out to you here. We're going to take it back to the angle. We're going to see, can we get back to 35 degrees based on these numbers? You say, well, how are we going to do that? Watch and see. All right, let's go to the calculator. We're going to use the inverse. So let me clear off what we've got there. We've got those lovely numbers. Goodbye. We're going to take the inverse sign, which, by the way, when we hit that, we go second, and it gives us a sign. It's got that cool little -1. That means inverse, all right? It's the inverse sign. And what we're going to do is we're going to put that ratio that we have set up. You say, well, what's the ratio, Ernie? It was x over 15. Now we know what x is, so we're going to put that 8 6/10, and we're going to divide it by the 15. Close the parenthesis, and I'm hoping I'm going to be close to 35 degrees. Now, we'll probably have a little bit of round off here, because remember, we rounded off to 8.6 or 8 6/10 there. Let's hit it. There it is, 34.98, almost back to 35. If we didn't have if we'd taken out a few more decimal places, we would be hitting right about on 35 on the money. All right. So, and we could have done the same thing with cosine, using, of course, 12.3, and that would get us back to the 35 degrees also. It's an amazing world of trig. It's a great, fun place to go, and I encourage you and tell you enjoy it when you get out there in the high school level.